Hello everyone. Today we are going to introduce you to the determination of total and volatile solids in organic feedstocks. This short video is just to get people who are not familiar with these two terms or terminologies about what total solid mean, what volatile solid mean, and how can we determine them in laboratory. If we look at the organic matter composition, we will find that it's composed of mainly two components, water and solid material. Water here represents the moisture content in the material, and the solids represent the total solids, or the terminology is total solid. The total solid composed of volatile solids, Vs, and ash, or this basically is a fixed solid. Sometimes people actually refer to ash as fixed solids. If we look at the volatile solids, which is Vs here, it can have biodegradable fraction and non-biodegradable fractions. But today, we are going to determine them in the laboratory without actually differentiate between what is the fraction in the material to be biodegradable and what other fraction to be non-biodegradable. The method that we are going to use today, or to explain today, is just to determine the total solid and the total volatile solid. It doesn't actually distinguish again between the biodegradable or non-biodegradable fraction. Again, this video is for maybe undergraduate student or with people who are not familiar with this two terminology. How to determine the total solids? There are many standard methods for examination of this total solid. Among them is the standard method for the examination of water and wastewater. And here you can find the method number 2540D. The total solid here is the material residues left in the vessels after evaporation of a sample and its subsequent drying in an oven at a defined temperature. So basically, this is the total solid. What we mean by this statement here is that we take a sample. Here we can take a volume of wastewater, for example, or a weight of material like biomass material, put them in a weighing dish or a crucible, for example. We put them in an oven under certain temperature, and after a certain time, we weigh again. So we weigh again after we cooled them down. So basically, the procedure, first we have to weigh the empty dish, put the sample in, and then of course, we have to weigh this empty dish, and then weigh the dish with the sample, and then put them in oven for a certain time. For this standard method, we have to have a temperature between 103 to 105. For wastewater, the standard method here is asking for at least 1 hour, 1 to 2 hours under this temperature for wastewater. However, for biomass material, you can find some references that use a time for about 24 hours to make sure that all water in the material is evaporated under this temperature. Again, we put the material in the oven for this period of time, and then we take them out, put them in a desiccator to cool down. The desiccator here just to prevent water to be absorbed by the material again. And then we weigh again. So basically, weigh the dish empty, put the sample in, then put the sample with the dish or with the crucible in the oven for a certain time, and then after cooling down, weigh again, and then now we can get the difference basically in the weigh. So the difference between the sample and the total weight of the sample and the dish minus the empty dish give you the sample amount or the sample weight. And then after we dry them at 103 to 105 for 24 hours or for 1 hour, and then get this difference, get you basically the weight after drying minus the weight before drying, give you the total amount of water that evaporated basically. And then the leftover after the drying, this basically if we subtract the total weight of the dish and the sample after drying minus the empty dish, this give you the total solid in the dish itself. So basically it's very simple procedure, but this again, this for people who are not familiar with this one. So then again, we put in the desiccator and then we calculate the total solid in this case. And also, again, we can also calculate the moisture content by the difference in weight. Okay, so then if we take this material and we put after drying or the material that we just tested and we weighed them after drying at 103 or 105, we put them in a muffle furnace for some time. Basically, we can just burn or actually combust the organic material, or the temperature here for this procedure is 500 plus or minus 50 degrees C for at least maybe 30 minutes. This is basically, again, this just to make sure that it's completely combusted and the organic matter is volatilized. Basically, volatilized means that all of these organics just gone during this kind of combustion. And the leftovers after this give you the ash or the total fixed solid. So basically, this is the non-carbon part contained in the compound or contained in the material that is being tested. Then what after we burn them for this period of time, sometimes also you can find references that can go for maybe 1 or 2 hours. Again, there are actually several methods that is reported in the literature for this, but maybe if you would like to have the standard method for examination of water and wastewater, you can refer to this method here, 2540E. Okay, after we combust them, we also put them again in the desiccator, and after cooling down, we weigh again. So basically, based on the difference in the weight between the dry matter and the dry matter mean here, this is the total solid that is calculated in previous step after drying itself, and minus the amount of the leftovers after the combustion here. This give you the amount of volatile solid. Basically, the remaining after the muffle furnace give you the total fixed solid or the ash. Okay, so very simple actually. Again, very simple calculations. If you have the total solid, basically it's the weight of the solid material in the sample divided by the total sample weight. Again, the total the weight of the solid in the sample, this can be determined after drying and divided by the total sample that you used in the dish or in crucibles. And most of the time, the standard method states that you have to take the total sample to be enough to produce something like 200 milligram of solids in the sample. This is basically in the wastewater samples. However, for biomass, it's not really homogeneous, and it may be actually you have to have a bigger amount of solid to be representative of this kind of material with non-homogeneity nature. Again, if we refer to the weight of the solids as WS and the total sample, again, this WS and WW, this is basically the weight of the solids and the weight of the water or the moisture content here. This is basically the moisture amount, or the amount of moisture in the sample. The moisture content again is similar to this one, but instead of actually having the total weight of the solids, we have the total weight of the water in the sample itself. So basically, the weight of water in sample divided by total sample weight. This basically either this equation just to give you the fraction of the solids or the fraction of the moisture in the material. If you multiply by 100, you can get it as percentage here. The volatile solid again, the volatile solid can be reported as with basis, basically based on the total mass of the sample. So basically you divide the weight of the volatile solid divided by the total weight of the sample, which is the weight of solids plus weight of water. Or it can be reported also, this may be the common actually way of reporting the volatile solid as fraction of the total solid. So basically here, this is the weight of the volatile solid divided by the weight of solids in the sample. So basically this is Vs divided by Ts. This is the weight of the solid, means that the amount of solid in the sample. Again, this also fraction can be percentage of. If you would like to have it as percentage, you have to multiply by 100. Here is just example how these values are reported for selected food waste. For example, here for source separated food waste, you can have moisture content again 69.1. In this case, if you subtract this value from 100, you can get the total solid. So basically, in this case, you can have total solid about 30.9%. And the volatile solid per TS or Vs per TS is 85%. So this again, the volatile solid here is a measure for the organic matter that can be combusted at 500 degrees C plus or minus 50 degrees C. Again, maybe some other material, you can actually have different values depending on the source of the material. Even this source actually can change from one country to another. Okay. Again, this again, if you have this Vs per TS is 85%, so you can expect that the ash is about 15% of the total solid. So basically, also this is based on the difference between 100 of percentage of the total solid here. Again, this is just a very quick example of how to determine volatile and total and volatile solids. And again, this volatile solid and the total solid are very important for reporting something like biogas yield or